Now, if we start with thinking like a quantum field theorist, quantum gravity is for a quantum field theorist the problem of how to do quantum field theory, which is invariant under diffeomorphism variance and perhaps some other transformations, gauge transformations. And one of the key problems there is how do we find local observables or beables that could make sense in a diffeomorphism invariant theory. Now, it will become apparent, and many people will feel curious about how I could have such an anti-de feeling, but I'm very much a realist. So my objection to quantum mechanics is that it doesn't give a complete description of individual events and processes. I don't care whether it's deterministic or stochastic, but I want that complete description of individual processes. And I believe that why that's hard is because those processes are expressed in terms of the evolution of relationships amongst physical degrees of freedom. That is, I'm very much of a relationalist in the sort of spirit of Leibniz, and I'll be, again, making that clear. So Leibniz had two great principles. Leibniz, to my reading, and what I read mostly is the monadology, had two great principles. One of them is the principle of sufficient reason, that for every distinction that might be in the universe, there must be a good reason for it. And if there's not a good reason for it, well, then it must not be a good question. So if you ask, why is the universe here and not 8 meters to the left, it's hard to see giving a sensible answer to that, because all the interactions we know about are about relationships and relative distances, and they don't change. So the right answer is that there is no meaning to where the center of mass of the universe is. What matters is only relative coordinates. So that's the kind of reasoning is involved there. He also proposed the identity of the indiscernible, that if these relational or relative degrees of freedom don't distinguish two events from each other or two objects from each other, then you're mistaken that there are two of them and there's just one. And that plays an important role at several parts of this development. Particularly, symmetries become incoherent. You can have gauge symmetries, but it doesn't make any sense to talk about a motion that brings the universe to a state which is identical to the one that was in. Now, how do you construct observables that live up to these high ideals? And the key idea of the whole talk and of the developments I'm talking about is to steal an idea which is central to Leibniz, which is that you do it from the inside. And here Fotini Markopoulou was most influential on me in her point of view of the universe from the inside. So the way I think about it is that the observables are what observers observe in the universe. That is, I'm an observer. I look around, I see the couch, there's the dark, there's the park, there's the lamp, there's the painting. And this is my neighborhood. And it's constructed by light signals, by photons that come to what I might think of as a little sphere around me, where I'm looking through to see the past. And this I call my view of the universe. And every event has a view, which is, roughly speaking, whether it's discrete or continuous, the past light cone, the causal past, and it contains the information coming up to form that event from the causal past. And the view that I'll take is that we are going to construct our theory of nature from views. That is, we're not going to talk about, as if we were outside the universe, where things are. We're going to talk about, we're not going to have space, and space will be, quote, emergent and will come later. We're going to talk about what are the different views of the universe. And we're going to build a dynamics which depends on nothing but distinctions between the different views. And by the principle of the identity of the indiscernible, the dynamics has to enforce that all views are distinct. And we'll see how that happens. This talk is a little bit of an intellectual autobiography, just a slight bit. But I think it's important to understand why I've taken the commitments and the views that I have. And I wouldn't usually explain that in a quantum foundations or even a quantum gravity talk, because for me, the most important idea that I've become convinced of and that I'm working to realize is the reality of time. And the idea that time goes all the way down. And by time, I mean the processes that make continually new views, which are views of events. And related to the idea that time in that sense is fundamental is the idea that the laws evolve, that laws are not platonic, absolute structures which are outside of nature and exist for some mathematical reason. I think that we've thoroughly failed at realizing that idea, but that the laws are part of nature that evolve. And the time they evolve in is fundamental and more fundamental than the laws. And I can later come back, I have a critique of why the standard view that the smaller you go in distance, the higher you go in energy, the larger symmetry you confront, and that particle physics involves a big spontaneous breaking of a big symmetry. And I think that that methodology is at a dead end and has indeed never explained anything. Because to break the symmetry, you always need more parameters than you're explaining. And it just, that seems to be a dead end to me. Many people persist in doing that, but it seems to me a dead end. The important lesson, so that's a dead end. And I began thinking back in the late 70s and 80s, how could we explain where the laws come from, how nature chooses its laws? And basically, I began to worry about the same thing with the anthropic principle people were starting to worry about then, which is why the laws seem to be chosen to give much more structure and complexity than would otherwise be apparent. And that also is books and books of argument if somebody wants to argue about that. And that the only way to achieve a world that was very complex in this kind of haphazard way is if it were the result of evolution. And this Charles Sanders Peirce, the great American pragmatist philosopher, was a key person in. So I took the idea from biology that laws evolve on a landscape to increase the fitness, not of a species, but of the universe, and made a little toy scenario called cosmological natural selection about how the laws evolve. But if the laws evolve, they evolve in some time, and that means that time is more fundamental than the laws. And that means that the Wheeler-DeWitt picture, that time emerges from the Wheeler-DeWitt equation, can't work. And the idea that the Wheeler-DeWitt equation comes, of course, I was very happy with the idea that the Wheeler-DeWitt equation came first and everything emerged from it, because Ted and Carlo and I had the great pleasure of solving the Wheeler-DeWitt equation and finding an infinite number of solutions. So of course we were hooked and we loved it. But as time went on, there were real problems realizing that picture. More than, there was the problem I'm mentioning now, and there was also technical problems implementing that. So I came to the conclusion that time is fundamental. And that's the most important change of mind I've had From quantum gravity, there's another set of arguments which trace to another bunch of papers that space is emergent, but time can't be emergent. Time must be fundamental. And that's a lot, again, some other time I could trace that logic, but that's what the books are for, was to trace the logic. And finally, from quantum mechanics, I, as a realist, wanted a non-local hidden variable theory. And as I'm a relationalist, that should be a hidden variable theory whose degrees of freedom are relations between other degrees of freedom. And thinking about how to realize that dynamically leads to the view that time is fundamental. So that's why it's the confluence of those three directions that put me in the position of believing that time is fundamental. So I'm going to talk a little bit about kinematics of this causal theory of views, and then talk about dynamics, and then I'll make the main claims. So I'm going a little bit faster to leave time for discussion. So sometimes I call this theory the dynamics of difference. And it starts like all theorizing starts by asking what is real? What do we put on the table as fundamental? And I put on the table events, their causal relations, and I'm not just a pure causal set fanatic. I believe that energy and momentum are fundamental and are transferred from event to event by the causal relations. And this is the main idea that Marina Cortez and I worked on what are called energetic causal sets. And I want to transmute that theory that we developed into a theory of views, that is, where the degrees of freedom are not the events and their causal relations, but the views of the events of their past as seen through the causal relations. And I can construct theories where the fundamental action is a function only of the views and contrast and differences of the views. And I'll skip, there's a relationship to topological field theory and spin foam models and Chern-Simons theory, and there's a whole lot of interesting technology there, but I'll skip that on this talk. So what is emergent in this theory? Space. There's no space fundamentally. Space-time, quantum mechanics, because I have P's and E's, but I don't have T's and X's. So there's nothing to build a canonical commutation relation around fundamentally. How is dynamics defined? By what we call a half-path integral, that is a sum over the causal processes, an integral over momentum and energy they transmit, but not the location of these processes in a background space-time. What replaces locality and distance? Well, normal dynamics that we deal with in theoretical physics is based on the pre-existence of space. So we have fields that are functions of points on space. They have derivatives, we can integrate them, etc. What are we going to replace all that technology by? And the answer is distinctions between views. So what I believe we do have is a space of views. We know that the views have to do with the energy momentum coming from past events into the present events. And we can parameterize or describe that space of views and put a metric on it related to the metric that we could put on momentum space. So that I build in, and that's it. The dynamics of the theory is a theory of views and the flow of energy and momentum.